In our second tutorial, we will add, subtract, and multiply complex numbers. So let's flip over to this section and we're going to be adding, subtracting, and multiplying complex numbers. A complex number has two parts. It has a real part right here, the 2, and it has an imaginary part right here, the 5i. So altogether, this first complex number is 2 plus 5i. The second complex number I'm using is -7 plus 2i. Now I know that I'm adding these two complex numbers because I can see a plus sign in between them, and it's very important for you to note what operation we're doing with them. If we're trying to add two complex numbers, that's pretty simple. I just take the real parts and add them together. So 2 plus -7 gives me -5. I take the imaginary parts, the 5i and the 2i, and add them together. 5i plus 2i makes 7i. So my final answer, -5 plus 7i. Really simple. My second example, of course, I'm subtracting. How do I know this? There's a minus sign in between. What I might like to do is sort of distribute this negative into the second complex number. The 2 plus 5i is really just kind of sitting there as 2 plus 5i. It doesn't need to be in parentheses. I'm just putting it in parentheses to show you that this is the first complex number. I'm subtracting -7. That means plus 7. I'm subtracting 2i. That means minus 2i. Oops. Change that. That might be a little bit easier to do. Now I'm back to adding ultimately. I'm going to put my two real parts together. The 2 and the 7 make 9. And I'm going to put my two imaginary parts together, 5i and -2i. That, of course, adds up to be 3i. And now I'm finished. So subtraction can get a little bit trickier because you're subtracting both parts of the second complex number. Finally, my last one, since I don't see a plus sign, I don't see a minus sign, I must be multiplying. And this is a simple FOIL problem. When we're multiplying two binomials together, we typically use the FOIL method, which means we'll multiply the first terms, and then the outer terms, then the inner terms, then the the last terms, and then we'll get our like terms together if we have any. So our first terms, we distribute 2 times -7 and get -14. And then we'll go to our outer terms. That's the 2 times the 2i. 2 times 2i makes 4i. I'm going to try and color code here. Then we go to our inner terms. 5i times -7. That makes -35i. And lastly, our last terms. 5i times 2i. Well, 5 times 2, of course, is 10. And I times I is I squared. Now, when I'm multiplying complex numbers, if I ever see an I squared, that does not last long in my problem. If I see an I squared, I know that I squared is equal to -1. So if I have 10 times I squared, I know ultimately I have a 10 times a -1, which is -10. So once you see an I squared, or really any power of I that's bigger than just I to the first power, change it using your powers of I tutorial that we just learned. 10 times I squared ultimately is -10. And now I can see that I have two sets of like terms. I have this -14, I'll circle that, along with this -10. And together, those add up to -24. And then I have another set of like terms. I have the 4i, I'm going to underline that, and I've got the -35i. Those are like terms, and those combine to give -31i. And now I'm finished. So these are the three operations that we will work on: addition, subtraction, and multiplication. Please pay attention to what operation sign is in between your complex numbers. Let's look at example 7. I have -2i, and I'm multiplying that to 3 plus I. Well, this is a simple distribution problem. So I'm going to distribute here, and I'm going to distribute here. Negative 2i times 3 is negative 6i. Negative 2i times I, negative 2 times the 1 is negative 2. I times I is I squared. Again, I see this I squared. That does not last long. I'm going to take this whole term. This is negative 2 times I squared. I remember I squared is negative 1, so negative 2 times negative 1 turns into a positive 2. That's what I do. I put a single slash right through my term and know that it's ultimately going to become the opposite of the coefficient because the I squared becomes a negative and the negative times the coefficient turns it to the opposite. So I had a minus 2 I squared, now it's a positive 2. And that's all that I have. I've got negative 6i and then a positive 2. This does seem a little backwards because our complex numbers should be written in standard form, which has the real part first, which would be the 2, and then the imaginary part, which would be the negative 6i. There we go. And let's look at our example 8. First of all, do you see something that's curious about these two complex numbers? This one is 5 minus 6i, and this one is 5 plus 6i. This is a special pair of complex numbers, and they're called conjugates. And this is our vocab word, conjugates. We're about to multiply a pair of conjugates, and we're going to see what happens. Conjugates, ultimately, you're just changing the middle sign. So if you have 5 plus 6i, the conjugate to that would be 5 minus 6i. The first parts stay the same. The last parts, I guess, stay the same as long as you change the signs. So those are what conjugates are. Let's see what happens. Of course, we're multiplying these two conjugates because there's no other operation. So let's multiply. 5 times 5 and 5 times 6i. 5 times 5 gives me 25. 5 times 6i gives me 30i. Let's do the under. I've got negative 6i times 5. Negative 6i times 5 is negative 30i. Maybe I'll stack up my terms that I know are going to be like terms. And then negative 6i times positive 6i. Negative 6 times positive 6 is negative 36. I times I is I squared. Again, this term, as soon as I see the I squared, that's not going to last long. I'm going to take that out. Negative 36 times negative 1 becomes positive 36. And now let's see what we've got. We've got all these terms. The positive 30i and the negative 30i, whoop, those are gone. They cancel away. I've got 25 plus 36. Well, that adds up to 61. And that's what's weird. When you multiply two conjugates together, your inner and outer terms, your imaginary parts, will cancel away, and you will be left with a real number. That's kind of a neat little pairing. So I want you to understand why these are conjugates, because the sign in the middle has changed, and that when you multiply them together, your imaginary stuff will cancel away, and you'll be left with a real number. Conjugates. I also want to show you one other thing, and I'm going to allow you to use this as a checking tool. This I, this number I, is on our calculator. If you pull up your calculator, I is right here above the decimal point. It's in blue on my calculator, so of course I have to push the second button, the blue button, and then I can access it. So here's our I. Anytime you need to plug in I into your calculator, it's right there above the decimal point. So let's make a note of that. I is second and then the decimal point. So we have to push the second button and then we push our decimal point. Let's make a big bubble around that. This can be used as a checking tool. Of course, I need to see all of your work in your problem, but in the end, if you'd like to check your answer, for example, let's check this FOIL. Let's plug that into our calculator. So I'm going to clear that out. I'm going to put the parentheses and then I'm going to type in 2 plus 5i. 2 plus 5i, and I'm going to close my parentheses. There's my first binomial. The second one is negative 7 plus 2i. Here's my second binomial. My two complex numbers, I'm going to multiply them together. Boop, the calculator does it really fast. I get negative 24 minus 31i. Hey, look at that. I've checked my answer. So you can use your calculator as a checking tool. Of course, I still need to see all of your math in the middle. So that's how you can check that. What I'd like you to do is try 3. Simplify this following all the operations that you see. If you'd like to, in the end, check it on the calculator, that would be a good idea as well. Why don't you pause right now and do try 3 and get your simplified answer. Pause now. So thanks for trying try 3. The first thing I saw I needed to do was distribute this 2, so I did that, and then basically got everything out of parentheses. And then I combined my like terms, and you should have gotten 12 minus 14i. If you practice that on your calculator as well, that's great, but remember, I need to see the work if you would like to get full credit. Moving on to example 9. It says to write each in a plus bi form. This is our standard form for a complex number, the real part and then the imaginary part. So the number 9, if I want to write that as a complex number, obviously it's missing one of the parts. 9 is a real number, so it's missing the imaginary part. But that's okay. I could write it as 9 plus 0i. That would be written as a complex number. Because there is no imaginary part, I need a 0i right there. And the same sort of thing here. 3i is a pure imaginary number, so clearly it's missing the real part. But that's okay. I could just put 0, and then since this is positive 3i, it needs to be plus 3i. And I could write that as a complex number. I could write any number as a complex number as long as I show a spot for both parts. Sometimes your spots will have a 0 in them because they don't exist. Okay, and example 10. Let's look at this one. It says to rewrite negative 1 as a power of I where the exponent is between 25 and 33. Let's first understand what we're trying to do. We want to write I to a certain power, and we want that to be equal to negative 1. So let's first talk about what powers of I are equal to negative 1. Well, negative 1 is equal to I squared. That's the main one, that I squared equals negative 1. So I squared would be one of the answers, except we want the exponent to be between 25 and 33. So obviously 2 is not in between there. So we need to keep going. I know that this is a pattern of 4s. So if I squared is negative 1, then the next one would be I to the 6th, because we're just adding 4 to the exponent. And then the next one would be I to the 10th. But 2 and 6 and 10, these are not numbers in between 25 and 33. So we would need to continue I to the 14th. And you know what? I'm not going to write them all down. I'm just going to do some math in my head. I'm adding 4 to get to 6, and then 10, and then 14, and then 18, and then 22, and then 26. Oop, 26 will do it. I to the 26th. And 26 is in between these two numbers. So I to the 26 is an acceptable answer. Let's keep going. How about I to the 30th? That would be the next one. Again, I'm just adding 4. And 30 is in between these two. How about I to the 34? That would be the next one. Oops, wait, 34 is too big, so that's no good. And all these other ones are no good either. Although it's nice to start the pattern to get to our 2 answers. And here they are. So that's one way you could do it. You could take your negative 1 and equal it to the first power of I squared, and then just start adding 4 to the exponents until you get to a number that's in between here. Another way that you could do it, remember I showed you a calculator trick. If you're looking for something that's equal to negative 1, on the calculator, if you divide the exponent by 4, you're looking for the decimal of 0.5. So if you take 25 and divide by 4, you would not get the 0.5. If you take the next number, 26, and divide by 4, you're going to get the 0.5. So that means that this is the first of the answers. And then you could add the 4, or you could keep dividing. Divide 27, divide 28, divide 29, and so on and so forth. You would see that 26 divided by 4 and 30 divided by 4 are the only two numbers in between these that give a decimal of 0.5. So these are the only two answers to this problem. So lastly, I have a fun problem for you to try. Here's try 4. What I want you to do, I want you to create one expression that involves addition and multiplication, which would simplify to this answer, -2 plus 9i. I want you to show your work so that you can validate that it is true to me and to yourself. And I have a little hint here, see try 3. Ultimately, I want you to create some sort of problem like this that involves addition and subtraction such that the answer is not 12 minus 14i, but is -2 plus 9i. Obviously, there are infinite answers. I'm just going to put that there are various acceptable answers here. Don't write this down. Of course, write your work, and I can check that in class as the last problem in your notes. So thanks for watching this tutorial. Please try 4, and I will check that when we get into class. See you then.